Welcome back for the final lecture of our library management use case. We've established a stable foundation using encapsulation. Now, we will introduce inheritance to create specialized book types and use polymorphism to treat them all uniformly within our system. 1. Defining the EBook subclass. We create the EBook class, which inherits from book. In its constructor, it accepts an extra attribute, file_format. We use super.double_init_, to initialize the inherited attributes, title, author, and ISBN. This is inheritance in action. Then we demonstrate polymorphism by overriding the get_details method. We call the parent's implementation using super.get_details and simply append the new, specialized detail. 2. Defining the AudioBook subclass. We follow the same pattern for AudioBook. It inherits common data from book, but adds duration_minutes. It also overrides get_details to include its specific duration information. The inheritance ensures code reuse, and the overriding ensures specialization. 3. Testing polymorphism in the library. We instantiate our specialized books. Now watch how the my_library.add_book method, which was designed only to accept book objects, accepts both the EBook and AudioBook. This is possible because of inheritance. They are both considered types of book. 4. Polymorphic output. When we call my_library.list_book, the library iterates over its list. For each book, when it calls the get_details method, it automatically executes the correct, specialized version, whether that's the base book method, the EBook method, or the AudioBook method. This is runtime polymorphism, allowing the generic library code to handle diverse, specialized objects seamlessly. To summarize, the library management system demonstrates the practical power of all 4 OOP pillars working together to build flexible, maintainable code. This brings us to the end of the OOP section. Next, we are going to a new section, Section 22, and our next lecture is 22.01. Introduction. See you there.